All right, so for this particular problem, it says consider the graphs of the parent log function f and the transformation of the function g. So f is just the regular, it's just a regular log function, right? So it's the common log function. In other words, f of x is just log of x, log base 10 of x. Remember, if I don't write down the 10, it's there. Okay, so this is referred to as the common log. It's a common log because we use a decimal system, a base of 10. That's how we count. Ones, tens, hundreds, thousands, those are all multiples of 10. All right, so now it says to produce g, f is reflected over the x-axis. All right, so remember, Mr. Adams said there's only one way to reflect over the x-axis, and that's to take the negative of the parent function f of x, right? Because what that does is if there's a positive value here, to make it a negative value, I just multiply it by -1. All right. But now, if you notice that this is shifted over, so if it was truly modeled, right, if it was truly flipped over the x-axis, it would look more like this, right? But it looks like it's been shifted 2 units to the left, right? So right here, it looks like it's been shifted to the left 2 units, okay? All right, so now I got to write the graph. So here's the interesting thing about shifting over 2 units. If I write -2 or +2 on the outside, that's the vertical shift. In order for me to get the horizontal shift, it has to go inside the parentheses. All right, and it has to be the opposite. So if I'm going 2 units to the left, which is normally the negative x direction, in here I have to, it has to be minus the minus. So it becomes +2. So right here, it's going to be g of x is equal to negative f of x plus 2. And if I wanted to shift that up or down, I could add or subtract a number down here. But that's basically it on that one. And again, basically what I'm doing is there's probably some data. Where this comes from in the real world application is maybe I collect some data on something, right? And that data I collect, has little dots. And those little dots kind of fit this pattern. I don't know what it would be. Something with a negative y value. Actually, I'm going to change that to black. So I collect a bunch of data. That data kind of takes on this shape. I want to be able to predict, what those parameters are. So what I do is I come up with this equation and I plug in a value for x and it'll spit out a corresponding y value. That's why it's important to learn how to transform the graphs. And maybe we'll do one of those examples in a minute.